what you see here is all of the, well, not all of, some of the components that I give you as a hint, right? So I mentioned that I'm going to walk you through setting up the surface normal using surface closest point, but that's just one of 3 components that I've been now teaching you about and kind of walking you through. So I'm going to walk you through that right now again so you can see it correctly, and then start to go through the number generator with you guys, because that's kind of a new idea. It's not quite something we've touched very much. So the surface closest point is going to require 3 other components in order to find a surface normal. Under the surface analysis panel, all 3 of those components are in this particular panel. Okay, so surface closest point is down here, and the other pairing to it would be evaluate surface. Now I mentioned that evaluate surface tells you that it is the last component you need in the line, right? We're moving left to right, so it's the last one you need, so it goes on the right, and that's because it has a normal output. That's the product we want. So then we work backwards. Working backwards, we say, I want to get a normal. In order to get a normal, I need a base surface and UV coordinates to test. Okay, so the base surface in this case is my original unbroken surface, right? And if I pull this aside and go back to the one that we're currently working on, why am I using the original surface? Think ahead to what we're doing. We're creating extrusions. So why don't I want a normal, and why don't I want a normal vector for every single one of these panels? This is important planning. You need to know this stuff. I'm choosing to use the original surface to eliminate redundancy. If I have 6 vectors for all 6 of these panels, they all face the same direction. I don't need 6 vectors. I need 1. And then all I need are 6 different magnitudes. That's where the number generator comes in. That's where amplitude comes in. So if I happen to have, say, a curved surface, or a surface that was truncated or faceted in some way, then they're all going to face different directions, and I would need every single individual normal. Does that make sense? Someday you'll get it if it doesn't now, or if it doesn't make sense now. So anyway, the other part of this is the UV coordinate value. So we're going to basically just straight plug in the UV output to the UV input of evaluate surface. And you've seen this 3 or 4 times by now. So the cool thing is now the evaluate surface is going to request a base surface. The surface closest point is also going to request a base surface. So they're both testing the same thing. So that's going to be my original surface here. So I'll plug that into S. I'll plug this into S. And the other component that I'm going to need in order to finish it all off, right, follow the orange back. This one is saying input parameter P failed to collect data. I need a point. I need a sample point. Generally speaking, I typically use the centroid of my geometry. You won't always use the centroid, but in most cases, a centroid is going to be a very sensible solution. So the centroid is found under the area tool. So surface analysis again, under area, it's going to ask for the geometry surface that it's testing, and it'll find you the centroid here. So I'll plug that in, and you can see that it's right there in the center, and then I can plug the centroid output into the P output. And now evaluate surface has created a plane on that surface, which gives me a normal output. Okay, so back to thinking about the end product. We're creating extrusions. The extrusions require the geometry that it's going to extrude and a vector, an extrusion direction. The vector that it's going to require has two parts. I've said this probably 5 or 6 times now in this class. A vector has two parts. What are those two parts?
Direction and magnitude.
Right, direction and magnitude. So the surface normal is which of those two parts? Exactly. It's the direction. Now, the other thing that I tasked you with was creating which of those two parts? Huh? Anybody? We already named one of them. What's the other one? I said it has direction and what? Magnitude, right? So I said generate a list of numbers that are going to give us a variable extrusion so it looks like this, and make it smart in parametric so that if I change the subdivisions it maps. So looking forward here, the amplitude is going to take a base vector, which is a direction, and a length value, which is a magnitude. So that is going to be my connection into the D input for the extrusion. So we already know that the normal is my direction, which would be this right here, so I'm going to connect my normal to that right now. And the last part here is going to be generating the list of numbers, which can be done a few ways. I mentioned that you could use repeat data with a panel, or you could use random. The choice is really kind of up to you. Random is basically going to take a range of numbers, and then the count of numbers, or number of numbers, and then you can seed it to randomize, basically change what the randomization is. So random is very simple. You just need to give it a list length to say how many numbers do I need, and then I want them to range somewhere in between this and that. So I'm going to release you again to move forward. You can choose one of these two options, and then I'm even going to tell you what you have to do with it afterwards. Once you generate that list of numbers that is smart in parametric, so if I change these, it changes as well. All you have to do is plug it into A, because that's your magnitude, and then I'll leave you to figure out what plugs in to B, which is your base profile curve or surface to be extruded. Any questions? Okay, I'm giving you guys 10 minutes for the rest of this.